Hello students, in today's video, let us learn about crystal systems and Bravais lattices. So based on different symmetries, there are actually 32 classes of crystal systems, and these 32 classes can be classified into 7 groups of crystal systems. So let us learn about these 7 groups of crystal systems and their basic properties. Now, different crystals, all the crystals can be broadly classified into these 7 groups of crystal systems. The difference between these crystal systems are due to the differences in their lattice parameters. So as you can see in this table, the characteristic features of the 7 groups of crystal systems are as indicated. Their lattice parameters defined by the vectors A, B and C, as well as the angle between these vectors alpha, beta and gamma are as shown in this table. Let us have a look into the features of the cubic crystal system. So in a cubic crystal system, all the axes are of equal length and they are all perpendicular to each other. So we can write A, B and C are all equal, and the angles between them alpha, beta and gamma are all equal to 90 degrees. So this one particular crystal system can exist in different variants. For example, the atomic arrangements can vary, like we can occupy atoms at the corners alone, which is called the simple cubic arrangement. Then we can put one atom at the body center, and that will be the body centered cubic arrangement unit cell. Then we can arrange atoms at the face centers as well as at the corners. That will form the face centered cubic structure. So this crystal system, the cubic crystal system, under this actually we can have 3 different types of arrangements, atomic arrangements, and those will form the Bravais lattices. So here we are concerned with the crystal system alone. So the cubic crystal system is one among the 7 crystal systems. Now the second crystal system is the tetragonal one. Here 2 of the 3 axes are of equal length and all 3 axes are perpendicular to one another. So this looks like a rectangular figure in 3 dimensions. So I can write A equal to B, but it is not equal to C. Along one dimension we have higher length and the angles are equal and all are equal to 90 degrees. So this can exist in 2 variants. One is the simple structure where atoms occupy the corners alone, and the second type is the body centered tetragonal arrangement. Now the third crystal system is the orthorhombic crystal system. In this arrangement, all the axes are perpendicular to one another, but all 3 axes are of unequal length. So we can write A not equal to B not equal to C, but alpha, beta and gamma are all equal to 90 degrees in this arrangement. So this can exist in all the 4 variants of atomic arrangements. The simple the simple structure where the atoms occupy the corners alone, the body centered orthorhombic structure, the base centered orthorhombic structure and the face centered orthorhombic structure. In a base centered arrangement, atoms occupy the center position of 2 of the opposite sides. So lattice points in the middle of each of the 2 ends are present in addition to the corner atoms. Now coming to the fourth crystal system, which is the monoclinic crystal system. Here all 3 axes are of unequal length and 2 axes are perpendicular to each other. So I can write the relation like A not equal to B not equal to C and alpha equal to beta equal to 90 degrees, which is not equal to gamma. So here only the variants of the monoclinic crystal system are the simple structure and the base centered monoclinic structure. Now coming to the 5th type of crystal system, the triclinic crystal system. Here all the axes are unequal and all the angles are unequal. So A not equal to B not equal to C, and alpha not equal to beta not equal to gamma, which is not equal to 90 degree. So this is a completely dislocated or completely slanted like structure with all the axes being unequal and all the angles being unequal. There is only one variant of this type of crystal system, which is the simple structure. Now the sixth type of crystal system is the trigonal crystal system. Here it is also called rhombohedral crystal system. Here all the axes are equal, A equal to B equal to C, and all the angles are equal, alpha equal to beta equal to gamma, but the angles are not equal to 90 degree. So there is some kind of equality between axes and the angles, but finally the system will be a little bit skewed from the cubic shape as indicated in this figure. It is not completely cubic shape, it is slightly shifted due to its difference in angle, but the axes are equal and the angles are equal. And finally, the seventh crystal system is the hexagonal crystal system. Here, two of the axes A and B are equal, but it is not equal to C. Along the third dimension, we have another length, and the relation between angles are alpha and beta are equal to 90 degree, but gamma is equal to 120 degree. So you can see here the angle between A and B is 120 degree since it is a hexagon, but the angle between C and A and the angle between C and B are all 90 degree. So we can see a hexagonal crystal structure will be formed if angles and axes are as indicated by this relation. So the only atomic arrangement that is possible in this case is the simple structure. So as we have seen, there are 7 crystal systems possible having different combinations and relations between the lattice parameters and the angle between them. So this table broadly depicts the relation between the lattice parameters and angles for different crystal systems. And within this crystal system, we can actually have different atomic arrangements. As we have mentioned, in the case of cubic system, we said that there is a simple cubic structure in which the atoms are present at the corners alone. Then a body-centered cubic system is there, and a face-centered cubic system is there. Similarly, for different crystal structures, crystal systems, there can be different atomic arrangements. And in 1850, a French scientist, Bravais, demonstrated that only 14 types of unit cells are compatible with the orderly arrangement of atoms found in crystals. If we take this crystal system, these 7 crystal systems that we have studied, we can actually have only 14 different types of atomic arrangements in them. So we have mentioned some of them. Now these 14 arrangements actually form the Bravais lattices. So let us see them. So here we have the 7 different crystal systems: cubic, tetragonal, orthorhombic, hexagonal, monoclinic, triclinic and trigonal. And within this cubic system, as we have mentioned, there are 3 different arrangements of atoms: the primitive or simple structure, then the body-centered one and the face-centered one. Similarly, for tetragonal system, we have the simple structure and the body-centered one. So for each of these crystal systems, different atomic arrangements are possible, or different unit cells are possible, and the different combinations of these unit cell and the crystal systems will form the 14 different Bravais lattices. So these indicated figures are the 14 different Bravais lattices. For cubic system, we have 3 different lattices. For tetragonal, 2. For orthorhombic, we have all the variants, the 4 different Bravais lattices. Then hexagonal, we have simple structure alone, the primitive structure alone. For trigonal as well, we have the primitive structure alone. For monoclinic, we can have the simple structure as well as the base centered one. In triclinic system, we have the primitive one, the simple structure alone. So these are the 14 different Bravais lattices that are possible with different atomic arrangements in the 7 crystal system. So I hope the basic concept is clear for you. Just go through the relation between the angles and primitive translation vectors of different crystal systems and try to understand about the Bravais lattices. Thank you.